The National Electrical Code, or NEC, addresses upgrading homes with aluminum wiring. Specifically, Article 110.14c covers this topic. It generally prohibits using aluminum conductors, aluminum alloy conductors, and aluminum-clad conductors as branch circuit conductors. This means, ideally, all branch circuits in a house should be copper. However, the NEC recognizes that aluminum wiring exists in older homes and provides an exception when replacing devices. This exception involves using copper pigtails. A copper pigtail is a short length of copper wire that's properly connected to the existing aluminum wire. The other end of the copper pigtail is then connected to the copper terminals on electrical devices such as receptacles, switches, and lighting fixtures. The connection between the aluminum wire and the copper pigtail is very important. It needs to be done with connectors that are specifically designed and listed for this purpose. These connectors are typically filled with a compound that inhibits corrosion, as aluminum and copper can corrode when they are directly connected. The NEC also has requirements for marking aluminum wiring. This ensures that anyone working on the electrical system in the future knows that aluminum wiring is present. The marking can be done with labels or paint and should clearly indicate that the wiring is aluminum. Upgrading a house with aluminum wiring can be a significant undertaking. It's essential to follow the NEC guidelines and use qualified electricians who are experienced in working with aluminum wiring. There are several important considerations when upgrading aluminum wiring. Firstly, identifying all aluminum wiring is paramount. A thorough inspection of the entire electrical system is necessary to locate all instances of aluminum wiring. This includes checking outlets, switches, lighting fixtures, junction boxes, and the main electrical panel. Secondly, proper connection methods must be used. Approved connectors designed for aluminum to copper connections are crucial. These connectors are typically filled with a corrosion-inhibiting compound to prevent oxidation and ensure a reliable connection. Thirdly, antioxidant compounds are vital. Applying an antioxidant compound to the aluminum wire before making the connection helps to prevent corrosion. This compound creates a barrier between the aluminum and copper, minimizing the risk of oxidation. Fourthly, torque specifications need to be adhered to. When tightening the connectors, it is essential to follow the manufacturer's torque specifications. Over-tightening can damage the connector or wire, while under-tightening can result in a loose connection, leading to arcing and potential fire hazards. Fifthly, proper insulation is critical. Ensure that all connections are properly insulated to prevent short circuits and electrical shocks. Use electrical tape or heat shrink tubing to insulate the connections thoroughly. Sixthly, grounding is essential. Verify that the grounding system is intact and functioning correctly. Proper grounding helps to protect against electrical shocks and reduces the risk of fire. Seventhly, arc fault circuit interrupters or size offer additional protection. Consider installing a size on circuits with aluminum wiring. A size are designed to detect arc faults, which are a common cause of electrical fires, and can provide an extra layer of safety. Eighthly, professional inspection is always recommended. After completing the upgrade, it is advisable to have a qualified electrician inspect the work to ensure that it meets safety standards and code requirements. Ninthly, documentation is crucial. Keep a record of all the work performed, including the types of connectors used, the torque specifications followed, and the results of any inspections. This documentation can be helpful for future maintenance and repairs. Tenthly, regular maintenance is important. Periodically inspect the connections to ensure that they are still tight and free from corrosion. If any issues are detected, address them promptly to prevent further problems. It is also important to understand why aluminum wiring was used in the first place. In the 1960s and 1970s, copper prices rose significantly, leading some builders to use aluminum wiring as a more affordable alternative. However, aluminum wiring has several drawbacks compared to copper. Firstly, aluminum expands and contracts more than copper with changes in temperature. This can cause connections to loosen over time, leading to arcing and potential fire hazards. Secondly, aluminum oxidizes more readily than copper. The oxidation process creates a layer of aluminum oxide on the wire's surface, which is a poor conductor of electricity. This can increase resistance in the connection, leading to overheating and potential fire hazards. Thirdly, aluminum is softer than copper. This makes it more susceptible to damage during installation and can also cause connections to loosen over time. When upgrading aluminum wiring, there are several options to consider. One option is to replace all of the aluminum wiring with copper wiring. This is the most expensive option, but also the safest and most reliable. Another option is to use copper pigtails to connect the aluminum wiring to the devices. This is a less expensive option but requires careful installation and maintenance. A third option is to use special connectors designed for aluminum to copper connections. These connectors are designed to prevent corrosion and ensure reliable connection. Regardless of the option chosen, it is essential to follow the NEC guidelines and use qualified electricians who are experienced in working with aluminum wiring. It is also important to be aware of the potential risks associated with aluminum wiring and to take steps to mitigate those risks. Here are some additional safety tips for homes with aluminum wiring. Firstly, never use standard outlets or switches with aluminum wiring. Only use devices that are specifically designed and listed for use with aluminum wiring. Secondly, do not overload circuits with aluminum wiring. Overloading can cause the wiring to overheat and potentially start a fire. Thirdly, do not cover aluminum wiring with insulation. Insulation can trap heat and cause the wiring to overheat. Fourthly, have your electrical system inspected regularly by a qualified electrician. This will help to identify any potential problems before they become serious. Upgrading aluminum wiring is a serious matter that should not be taken lightly. By following the NEC guidelines and using qualified electricians, you can ensure the safety of your home and its occupants. Remember to prioritize safety and consult with experienced professionals to determine the best course of action for your specific situation. Ignoring these factors can lead to unsafe conditions and potential hazards. Remember to always disconnect the power before working on any electrical circuits. Use appropriate safety gear, such as gloves and eye protection, when working with electricity. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Electrical work can be dangerous and should only be performed by those who are properly trained and equipped. Before starting any electrical project, obtain the necessary permits from your local building department. This will ensure that the work is done in accordance with local codes and regulations. Familiarize yourself with the NEC requirements for electrical installations. The NEC provides detailed guidelines for safe and effective electrical work. When working with aluminum wiring, use only connectors and devices that are specifically designed and listed for use with aluminum. Do not attempt to use standard connectors or devices, as they may not be compatible and could create a fire hazard. When making connections between aluminum and copper wiring, use an antioxidant compound to prevent corrosion. This compound will help to ensure a reliable and long-lasting connection. Torque all connections to the manufacturer's specifications. Over-tightening or under-tightening connections can lead to problems. After completing any electrical work, test the circuits to ensure that they are working properly. Use a multimeter or other testing device to verify that the voltage and current levels are within acceptable ranges. Keep a record of all electrical work performed, including the date, description of the work, and any materials used. This record can be helpful for future maintenance and repairs. If you have any questions or concerns about electrical safety, consult with a qualified electrician. They can provide valuable guidance and help you to ensure that your home's electrical system is safe and reliable. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before undertaking any electrical work.